Mr. Hinya. I hope you're all well. Today, what we're going to be doing is exponents, but we are going to be doing equations got to do with exponents. Okay, so there are three very important steps that I like to say all the time, and they are very important to follow the order of the steps. So, step one, I'm saying get the x part alone. I'll explain what that means. Step number two is to get the base or the exponents the same. And then step number three, make the base or exponent equal. So I'm going to take us through step 1, 2, and 3, every single question. And yeah, why don't we just go ahead and we can see how we do it together. So 1.1 over here, guys, what you're going to pick up is in blue, I've made specific questions. And then in green, I've put a different type of questions. They are still equations got to do with exponents, but I'm going to show you what you're going to pick up. So the first thing to pick up is there are two different types of sorry, let me just get a highlighter here, of equations in exponents. There is the first type where you'll see your exponent is the unknown, it's the x, and then in green here you'll see that then there is when your base is the unknown. So those are the two different types of equations when it comes to exponents and needing to answer them. So let's have a look at the first type in blue where what is the unknown? My exponent. So this is how we go about it. So it's 4 to the power of x is equal to 64. Now, let's follow our steps. Get the x part alone. When I say the x part, I mean wherever that exponent is and the base. So it's 4 to the power of x. That is what I mean by my x part. So it is already alone, right? There's no like plus 1 on the side, or there's no multiply by 3. It is just alone on that left-hand side. So step number 2 is get the base or exponent the same. So now in this case, when my unknown over here, when I know the base, you need to make this number on this side of the equal sign the same base as this. So my question to you is, how can I write the number 64? How can I write it the same as with a base of 4? So isn't 4 to the power of 2, which is 4 squared, isn't that the same as 64? Yes, so that is how I can write 64 with the same base on this side. So let's do that. So it's going to be 4 to the power of x is equal to 4 squared. And that is getting my base the same. Okay, can you see my base is 4 and my base is 4? I've gotten my base the same. Then step number 3, we're going to make, in this case, we're going to make the exponents equal. So my unknown is x here. So I can say x is therefore equal to, I'm making the exponents equal. So it's x is going to be equal to 2. Okay, guys, I took a little bit longer there, put a bit more explanation in number 1 so that we can follow the steps in the further questions. So let's continue. Right, so we have 2 times 5 to the x is equal to 250. So step 1, I said, guys, step 1 was that we need to get this part, the x part of my equation alone. So how are we going to do that? Well, you can see there is a times 2 here. So we need to get rid of this 2 here. And how do we do that? Remember the word inverse operation. If it's 2 times something and we need to get rid of it, we are simply going to divide by 2. Okay, because 2 divided by 2 is 1, so it basically disappears. And then over here, we need to do the same thing to the opposite or to the other side of the equal sign. So essentially, when we simplify it, it will be 5 to the power of x is equal to 250 divided by 2 is 125. So step 1 is done. We got a tick. Step for step 1, we got this part alone. And now we're going to make the 125 written with a base of 5. So 5 to the power of what gives me 125? It's 5 to the power of 3. So that's how we're going to write it. So we're going to write 5 to the power of x is equal to 5 to the power of 3. And then when we have made our base the same, that step 2 is done, then we are going to make our exponents equal. So then x will equal 3. Okay, let's have a look at question 1.3. So in this case, guys, there is just one rule of exponents that is essential for this question, and that is I already have my x part alone, like step 1 it always says, and now step 2 is I need to write 1 over 5 with a base of 5. Okay, just like I did here, I wrote 125 with the base of 5 because I need the same bases. I need a same base. If this is 5, the base of 5 here to the power of x, I need this. I need the right-hand side to be written to a base of 5 so that I can make my exponents equal to each other. Does that make sense? So how can I write 1 over 5? So how can I write 1 over 5 over here with a base of 5? So there's a rule of exponents that if you have something to the power of a negative exponent, it can be written like this and written to the positive 2, right? So now over here, if this is 1 over 5 to the power of an imaginary 1, and I want to bring this and make it a base like this, I can write this as 5 to the power of negative 1. Let's have a look. Can you look at this example? A to the power of negative 2 is the same as 1 over a to the positive 2. So 5 to the power of negative 1 is the same as 1 over 5 to the positive 1. So this is what I am looking for over here. So I'm going to write this over here. So it's going to be to the power of negative 1. And that is how I get the same base. And then step 2 is done. So I can just make my exponents equal to each other. X is equal to negative 1. Right, let's go ahead and do the same over here. So 2 to the power of x is equal to 1 over 8. Step 1 is done already. My x part is alone. So now we need to convert this, the 1 over 8, written with a base of, needs to be a base of 2, the same base as this unknown part over here. So how are we going to do that? Right, so the first thing that you can see is that if I write 2 to the power of x, it is still, would you agree that I can write it like this? Because 2 to the power of 3 is what? 8. So it would be the same as this. 1 over 8 is the same as 1 over 2 to the power of 3. Now, just like in this example, in example 1.3 over here, if I have 1 over 5, I can write it, if I have 1 over 5 here, I can write it as 5 to the power of negative 1. So over here, sorry, I'm a little bit all over the place here. So if I have 1 over 2 to the 3, and I just want it to be the base of 2, then I can write it as 2 to the power of negative 3. And that is a really important rule of exponents. So I can write it like that. So it'll be 2 to the power of x is equal to, now I can write this that I have over here, as this over here. So I'm going to write it like that. And therefore my exponents will be equal to each other. So it's x is equal to negative 3. And that's my final answer. Okay, let's go ahead and do 1.5. In this case, guys, again, I'm following the same steps, but this time, after step 1 is done, I'm going to show you what changes. So my x part is alone already, and now because I know my exponents, this side, this number over here, I ask myself, not how can this be written, not how this can be written with the same base, but how can 27 be written with the same exponent? So there's going to be a number with the same exponent as this exponent, okay? So 27, if you think about it, can be written as 3 to the power of 3. So that is kind of the question that you must continuously be asking yourself in these types of scenarios. So therefore, I can write x to the power of 3 is equal to 3 to the power of 3. Because why, guys? Isn't 3 to the power of 3 the same as 27? Absolutely. So therefore, now the last step is you can write the bases are equal to each other. So x is equal to 3, just like that. All right, let's move on and do, I think it's the last two. And then the next video, guys, we are moving to scientific notation with exponents. So let's finish this one off. So step one, we need our x part alone, and it's not alone because we have, there is a times 9 over here, which we do not want. So how do we get rid of the times of the 9? We need to do the inverse operation, which is divide. So we're going to divide by 9. And we need to do the same side over here. So it's going to become x to the power of 3 is equal to 8. And now, remember, the thing you must ask yourself is, how can I write 8 with a base and exponent, but the exponent needs to be 3. So how can I write 8 with a certain base that has the power of 3? So is it not 2 to the power of 3 is equal to 8? So let's go and write that in. So x cubed is equal to 2 to the power of 3. And we make our base the same. X is equal to 2. And we get our full marks there. Right, lastly, guys, over here, there's two things that we need to do in order to get our x cubed alone. So first we need to plus a 4. So let's do that to get rid of the minus 4. So it's going to be 2x cubed is equal to 246. And because I plus 4 on this side, minus 4 plus 4 gives me 0. So that cancels out. And I need to still plus 4 on the other side, because what you do on the one side of the equal sign is done to the other. So it will be 2x cubed is equal to 250. Then we got to get rid of the times 2 here. So we're going to divide by 2. Divide by 2. And that's going to give me x cubed is equal to 125. And then you ask yourself the question, 125, how can it be written with a base raised to the power of 3? Okay, and that is 5. 5 raised to the 3 is 125, so we can write that like that. 5 to the 3 equals, x to the 3 equals 5 to the 3. And then I can make my bases equal. So x is going to equal 5. And that is that, guys. That is how we do equations with exponents.